Here we go.
There we go.
Let's try that again. Okay, welcome for today's Rising Tide Foundation lecture, where we are very happy to once again be hosting our good friend, Dr. Michael Clarage, who will be delivering some very special Easter insights. I think this is a really special way and an appropriate and lawful way to celebrate Easter Sunday, where certain ideas that were once understood more naturally in society in better times past have to be revived once more if society as a whole is going to make it through many of the dangerous storms that in many ways, I believe, parallel the missteps humanity made, the leaps into folly and immorality back in the days of the Roman Empire, which a certain individual rose and stood up against and gave humanity something much more beautiful in opposition to the decayed and really deviant idea of what human nature is that was prevalent amongst the age of this Roman Empire, especially after the death of Cicero, when the Republic became a full-blown empire. This was a very important set of ideas, and in many ways, they created the seeds for the renewal of humanity that emerged in the Golden Renaissance and the discovery of this concept that man is made in the living image of the Creator as a creative force that could participate in creation itself. The idea of pace fidei and imago Dei were very, very important integral concepts to the revolution of discoveries in science and arts and statecraft that emerged in the 15th century. So once again, we are in desperate need, living in a time of empire, to have a revival of certain considerations that relate to how we should think about the nature of science, the nature of arts, and the nature of human beings, which create both and are in turn shaped by both. So Dr. Clarage is somebody who has made, I've noticed, a running theme throughout many of his recent contributions to the realm of scientific insight, and people who have seen his previous presentations on the electric universe and the principle of electricity and life and many others that he's delivered to many venues, including the Rising Tide Foundation, have gotten a sense of that. So, Dr. Clarage, I'm not going to say anything more. I'm going to leave it all to you and blow people's minds. When you're done with the formal presentation, as usual, we'll open up for Q&A.
Sounds great. Yeah, I'd forgotten that you were, or I knew that you were away and then back. So maybe at the end you can give us some highlights from your trip. That could be a little bonus. Okay, so yeah, this presentation, I've been wanting for a while to write a lecture on this topic specifically. Function. What is function in the cosmos? And then it was about 6 months ago or so, I was talking with an engineer friend of mine who I've talked about these ideas a lot with, and I just said something like, well, you know, that's the function of the magnetosphere. And he looked at me like, what do you mean that's the function of the magnetosphere? And that was kind of a reminder that, see, I think about these ideas a lot, and we all suffer from this, right? If you think about something a lot, then you somehow we still assume that everyone else we're talking to also thinks about these things a lot. And yeah, and so I really, I was like, okay, I want to make a lecture that's on this idea and try to flush out some of what I might mean by function in the cosmos. The example that I gave was when he asked me to think about it more, went right to the Earth's atmosphere, because I was thinking a lot about that at the time. And the Earth's atmosphere, let me see how let me just see how the video comes through, or I mean how the board comes through. If I do that, that's kind of small, isn't it?
Well, if we have you on full screen, I can see it very clearly. So as long as people are not using their cell phones, I'm sure they could see what you're doing.
Okay, and then maybe I can find another. The Earth's atmosphere. So we live on the Earth, and then the sun is, you know, way over here, and there's a very big difference between the two of them in a lot of ways. And one of the ways that they're different is their energy, how energetic they are. We live down here on Earth where there's liquid water, and there's trees and cells and flowers and wind, and there's ice. There's even ice down here. And then on the sun, it's such a more vibrant, hot, energetic environment. How can those two possibly live together, right? It'd be like throwing an ice cube into a fire. How do they live together? And it's been known for a long time now that the atmosphere that we're familiar with, the one that we breathe, has these layers to it. And depending on how you count them, you might say there's 5 or 6 or 7 layers. The bottom layer is what we live in. Why don't I just... No, I won't. Okay, so it's what we live in. And then we have names like thermosphere and ionosphere and mesosphere and troposphere. They're a little bit, no one can ever remember them, what the names are, because they're not really connected to what the function or the purpose of the layer is. And so we always forget them. But generally speaking, as you go up in the layers, the air becomes more rarefied. But strange things happen with the temperature, like the temperature drops and then it rises. The electron conductivity drops and rises and drops and rises. So there's a lot of complex changes that are taking place. And then when you get to beyond those layers, there's this other set of layers that come into play. And roughly, they have this name, the magnetosphere. And it itself is also multi-layered, lots of layers in there. Layers and then also structures, layers. Things get very complicated electrically when you go out. But then the very top layers of that magnetosphere are what can be in touch with what this word we have for the solar wind. How do you connect the two? Well, you're going to need at least an octave of layers between the solar wind and the electromagnetic body of the Earth, and then at least another 7 or 8 layers between as you go down through the molecular and gaseous bodies of the Earth. So that what I'm starting with is that these layers have to be there for reasons. It is not the case that it's accidental. It's not the case that it's random. It's not the case that the Earth just showed up at its current radius and then just happened to accumulate all these layers of atmosphere and electromagnetic scaling down. So that's my starting point, right? And of course we can argue that, but I'm just letting you know that's where we start from, is that it's all necessary. And the existence of life on Earth is very important to the Earth. I don't think we hardly understand how important it is. All the plants and the animals and the people. I think just repeating myself, I don't think we really understand how important it is for the Earth to have it. And the Earth is super important for the solar system. If you just took the Earth out, the solar system would probably fall apart. So the existence of life and you and me on Earth is tremendously important to the body of the Earth and hence to the body of the solar system. And that's what all these layers are needed for, is to maintain that, to keep that everything connected to everything else. And and in my mind, if someone says that that life on Earth is an accident, that to me just shows how out of touch such people are with reality. Yeah. Okay. I want to bring in the idea of, I mean, one way to put it is digestion, that the matter and energy in this world, sorry, I got something on my finger, needs to be digested by the earth. So what would be an example of digestion that we're familiar with? Well, we're familiar with here that sunlight is taken in by plants, and then they do things with that sunlight. They take it in, they do things with it, they incorporate it into themselves, they produce fruits and whatnot, you know, and then we take the plant and we put it into ourselves, and then it becomes part of us. So these layers could be seen as how the earth digests solar energy. Another aspect of this that I'm kind of becoming more, that's permeating my thought on this more, is the beauty. And I don't know if function is ever divorced from beauty. I'm starting to think it's not. I remember years ago reading a few books by Swedenborg, and he described how in heaven there's no space, in the sense, I'm sorry, no distance, in the sense of like meters and miles. In heaven, the distance doesn't exist like that, but there is a distance metric. And one of the measures of that distance metric in heaven is usefulness. If the more useful you are, the closer you are to the center, to the divine. The less useful you are, the farther away you are from the divine, from the center. And I'm starting to see that notion playing out in terms of beauty as well, that anything really that's functional, that's serving a purpose, that's doing a job, there is a beauty to it. There's a real beauty to it. And you can look at everything with nature, like any kind of a being, a butterfly, a spider web, our bodies, these pictures of the earth and the magnetosphere, there's a beauty inherent in all of it. And if beauty is not part of an explanation, I tend to think the explanation is on the wrong track. So for some reason, which I'm still pondering, the electric universe paradigm or model really facilitates my ponderings on this. I came across the electric universe paradigm in 2010. Wal Thornhill, who passed away in February, if you didn't know that, I encountered the electric universe ideas through him, through some of his discussions of supernovas. And that, so that was what, 13 years ago. And I think it's because electricity is the finest matter. Electricity and light are the finest matters that we really know, that we're familiar with. And it's a principle that I'll come to later, that the finer the matter is, the more it can permeate everything else, and the more it can orchestrate everything else. So I think that's probably why my ideas keep circling back to the idea that we must look at the electricity involved in anything, really, but in terms of space, certainly, in order to understand how it's working. There's also hierarchy. Hierarchy is a bad word in most scientific departments still, unfortunately. The idea that there will be a higher level than us, for example, something that's larger, more intelligent, more powerful, something that lives longer, etc. And I think we have to bring that in. It's one of the ways that contemporary science is stuck. Contemporary science is stuck in a lot of ways. It certainly is, but this is one of them. That the universe it hasn't incorporated the truth that we live in a universe that is worlds within worlds. Like, that is the blueprint, is that if you have a world, then it is a citizen of a larger world, and it is made up of smaller worlds. And that is a fundamental principle, that if we don't like start with that, everything's going to go off in terms of what we study and why we study it. So so let me just tie it back then to this picture. If one had started with the idea that we live in a hierarchical universe of worlds within worlds, and if one had started with the idea that life on Earth is critical to the Earth, and that the Earth is critical to the sun, if one had started with those from that, then one would not be surprised to see an octave of layers in the gaseous Earth and an octave of layers in the magnetic body of the Earth. You would expect such things, right? It's like an engineering problem. It becomes an engineering problem if you needed to connect the cold world of fish and people to the fiery world of the solar wind. How do you achieve that as an engineer? If you were the chief engineer to do that, right? Well, you would have to have these stepping down. It wouldn't be a continuous stepping down because the things don't work that way. You'd have to go down in stages and in steps in order to traverse that gap. There was a mission that went up right when I was preparing this called the ACES 2 mission, which was sent up to look at I'm just looking for a picture, sent to look up what's going on in the electrical circuitry of the Earth. And no, I'm sorry. I thought I had that. There we go. Okay, now I will share. Loopy doopy, I will share as soon as I find the picture. Okay, how do I share in Zoom? It's been a long time since I've used Zoom. Boop, boop, boop,
There's a green share screen button at the bottom.
There you go, bright green. No wonder I can't see it.
Are you colorblind?
No.
Okay. Sarcasm. Okay.
Exactly. I want window brave. Okay. No? Can you see my screen?
Yes.
Okay. The currents that connect the Earth to the sun are very complicated, and they have this when you get close to Earth, there's this delightful pattern where I'm just going to try to follow the arrows, right? So pretend your electric current. You come in at sunrise and then shoot back out, and I'll say where it shoots back out to soon. And then that comes back in on the other side, it's the sunset side, and then shoots back out again. It's not as simple as, electric current comes in through the North Pole and goes out through the South Pole. It's not that simple. There's always electric currents flowing. It's roughly 1 billion amps is flowing constantly through these little ribbons that I'm showing you here. It fluctuates quite a bit, but just to give you a ballpark. So again, it comes in, the currents come in, they go back out, and then they come back in again, the other side, the sunset side, and go back out. What's not really known is what's happening close to the Earth. So the artist who drew this was taking some liberties in terms of how these arrows what they actually do when you get close to the Earth. And so the ACES 2 mission that was its point. It launched in last November, was to fly several times through this region specifically to see what happens to these currents. And I was very happy to see that because I've known that it's a gap in our understanding. But I thought it was a good one to bring into this lecture because it's half a mission, right? Yes, it's good that it's looking to see what currents are coming in like this, okay? But the other half of the mission is what is going on the surface of the Earth with all, at the same time. That would make it more of a complete mission. Because if you don't think the currents are doing anything, or if you think they just happen to be there for whatever reason, then you're never going to understand what their purpose is, what their function is. If you approach this question with okay, there's currents going into and out of the Earth, they have to have a purpose and a function that is related to the Earth, then you would, at the same time, you would have a mission, or the other half of the mission would be looking to see what's going on in the Earth at the same time. Now, I know none of this is easy. I'm not trying to suggest that, oh, they could have just done this, right? Because you don't know whether you want to look at the lower atmosphere that we breathe, or whether you want to look at telluric currents, currents that are flowing through rocks, or whether you want to look through ocean electric currents. So I understand it's a very difficult question, but that would make it a complete mission, right? To see how the two relate. Now, I said I would say more about what's going on outside those regions as you go out and about. It gets really complicated, is what happens. It becomes impossible to draw in one picture the electrical circuitry, the electrical body of the Earth. So there's various ways you draw, and you leave out some things and you include other things. But I'll just try to show from here. Not that one. Maybe not that one. This one. Okay.
Wait, Michael. So we still see the first screen that you showed. So what you have to do is, I think, do a stop screen share, and then yeah, exactly. Now do it again, screen share, and pick whatever file it is. It's a bit annoying.
It is a bit. I want the whole window, and I want this window. Okay, so when I was talking about the electric currents coming in and going back out, here's the Earth in the center, and the solar wind comes zooming past, which is an environment of such extreme electricity that we can hardly even imagine. And the some of that flow comes into the Earth system, and it follows that trajectory I was talking about, where it comes into the Earth, but then goes back out. And when it goes back out, it goes into the electromagnetic body of the Earth. So one of our problems, because we're not very well trained on how to use our 5 normal senses, usual senses, is that we believe that the Earth is only the rocky bit. Like, we think that's the Earth, is the rocky bit that we walk around on. Okay, well, that is part of the body of the Earth, and maybe it would be analogous to the bones of the Earth, maybe, right? But the Earth and all planets, all suns, have an electromagnetic body, which is much larger than the rocky body. Okay, so when the solar wind comes past, some of that electromagnetic matters come in to the Earth, and then when they go back away from the rocky body of the Earth, they're going into the electromagnetic body of the Earth, and this forms a kind of circulation. And then the circulation comes back to the rocky body and then shoots back out to the larger world of the planets and the sun. So I'll just talk it through again. It's not trivial. The Earth is embedded in the larger body of the sun. We're swimming, so to speak, in the body of the sun, electromagnetic body of the sun. Some of that electromagnetic energy comes into the Earth, and then it goes back out to circulate through the electromagnetic body of the Earth, and it then comes back to the rocky body of the Earth, and then heads back out to the solar wind, or to the larger body of the solar system. This shows kind of a similar idea, but with more colors and more arrows. you have energies coming in, and then this large blue thing here, you can think of that is more like the body of the Earth, is this large blue structure here, which is plasma. It's electric fields, magnetic fields, charged particles. The plasma has an incredible ability to segregate, to form layers and to form tubes. It's easy to form a tube for electric current and magnetic fields to flow in a plasma. And we give them names like Birkeland currents or field-aligned currents. You've seen it with lightning strikes. But what they really, I mean, to bring it to our level of understanding, what they are is membranes. So plasma forms membranes, and they're semi-permeable membranes, meaning that just like our blood vessels, or just like the membranes around the digestive system, they have a function, they transport materials, but they're not, hermetically sealed plastic tubes, right? They're semi-permeable, just like the membrane of a cell. They have some things come in, some things go out. If conditions change, then different things come in and different things go out. So you really have to, when you see pictures like this of the magnetosphere of the Earth, it's appropriate to be thinking of it in terms of like veins and arteries and semi-permeable membranes. Okay, back to and so in one sense, long before the mammalian circulatory system was worked out, long before that, the Earth's electromagnetic circulatory system was worked out. There's often nothing new. So the same problems are always being solved at every scale in the universe. It's really just they might look different, and the physical laws that are being employed might be more or less important given the scale. So for example, gravity plays a big part in an Earth system. It helps, with those lower structures of the atmosphere, et cetera. Whereas in our cells, I don't think gravity plays a very big role in the functioning of the cell. But you're still solving the same problems. The Earth as a living system needs to be, it needs to have its own life, and then it needs to have a boundary where it stops and the world around it begins. And so nature's always solving that problem. How do you have one creature that lives amongst many others? It's kind of a basic conundrum. So following this theme then for what would make a more full mission, or maybe what would make more full ponderings, how, like in a biological system, an organ receives material, does something to it, and then gives back new material. So the liver, amongst its 10,000 functions, one of the things it does is, our livers, is that it receives proteins, and then proteins have to be humanized. They have to be modified slightly so that protein can function in a human system. And this is a huge, like a lot of these things, a mystery. You're like, well, how does our liver know how to humanize, 47,000 different proteins that we put into our body every day? I don't know. It just figures it out. And then the liver gives those back to the body so the body can use it. Okay, so it's worth pondering. The Earth, just like any of the other planets, it's taking in materials from the larger world that it's a part of, the sun. It's doing something with all of that input. And then my point being, it gives back. It gives something back to the larger system. And that's, if we don't think about that, we're going to be missing the importance. I guess it's related to what I was saying before about we underestimate how important life is. to the Earth, and then hence underestimate how we underestimate how important life on Earth is to the solar system as a whole. We may not, we don't understand exactly what's coming in, or it's so complicated, I should say, that it's difficult for us to understand. But you try to picture this. Okay, so the Earth is spinning, right? We're spinning, and those currents that I showed coming in and out to the rocky body of the Earth, they primarily, not entirely, but primarily are coming in on the sunset and sunrise sides of things. Okay, so pull back with your vision, pull back. You're looking down on the Earth, and the sun is on one side and the sun's rays are hitting the Earth. If you pull back, you see that the Earth is spinning, right? And there's really just one sunset and one sunrise. It's just the shadow. It's the shadow of the Earth. And so there's an electric current that's coming in at that sunrise shadow. And the Earth is spinning underneath there, right? And then there's an electric currents coming out of the sunset shadow while the Earth spins underneath it. So try to picture, there's 10 billion amps of very complicated electromagnetic substance coming into the Earth at sunrise, and then being harvested back out at sunset. So that means everything we do during the day, I mean, just follow the image I'm painting. We wake up, we live our lives, we go back to sleep at night. Well, where does all that energy go? We know that it's not destroyed, right? We know that energy matters can't be destroyed, but they can be moved around, right? So in this image, this electric image, everything that I do during the day, I lay down at bed at night and it all goes back up. It's literally sucked back up. A giant electromagnet is sucked back up and sent back into the larger body of the solar system. I don't know what it does up there, but I think it's worth acknowledging that that's the situation from an electromagnetic point of view. Now, the picture I showed with the currents coming in and going out, and that we don't know what happens at the surface of the Earth. So it could be that the electric currents from space go into the Earth. They go right into the Earth, and that literally might create the the magnetic field of the Earth, and then they come back out. But often in nature and in human electrics, things work by induction. So you can have a transformer where on one side the currents varying or back and forth and up and down, and then there's another transformer sitting right next to it, and the two don't have to touch. There's no direct electrical connection between the two, but the energy is transformed from the one into the other. It's called induction, through electromagnetic induction. So it could be that that's how planets interact with the solar currents, is purely by induction, because they're always changing. They're never constant, right? So that I think would be a good thing to know as a planetary scientist, is what's going on with that. Are planets connected to the sun through induction? Are they connected to the sun directly, it's like a simple flashlight battery circuit, or what combination of those two things? Okay, so now we will head into the blue didn't really erase very well, so I think I'm not going to use the blue. I should get the camera up so I can see how I'm looking. I'm going to go full screen. Come on. Why can't I go full screen? Oh well. So a person is a citizen of a larger world. In this presentation, we're just talking about Earth. And then the Earth is a citizen of this larger world that we've been talking about now for 15 minutes or whatever it is, the solar system. And all the solar systems, there might be two steps in here, but we'll talk about that in a sec, are citizens, members of a larger world. We call them galaxies. And again, there might be several layers up here. The large scale structure of the universe, you know, I'm sure you've all seen these pictures. The more the data comes in, the more the whatever the galaxies are a part of ends up looking more and more like a brain. You know, it's just, it doesn't look kind of like a brain. It looks exactly like a brain. But anyway, that's probably for a later discussion.
Michael, the what you're writing now at the very top, we cannot see, but we can see all the way up to galaxy.
Great. Let me see if I can sacrifice. Boop.
Perfect.
Okay, so what is a cosmos? A cosmos, as probably most of you know, it's a Greek word, and for the purposes of this lecture, I want to highlight that all I'm going to just throw it out there, you know, all cosmoses are built on the same blueprint. The master engineer blueprint, there's really just one blueprint, but then it has to be implemented at different physical scales. And so, as I was saying earlier, different physical laws might be more prominent or less prominent, and hence the specific cosmoses that exist there might look very different to our eyes, but the blueprint is the same. And so there's always this pattern of a cosmos is a citizen of, or you know, a member of, a citizen of a larger cosmos. I don't think we don't know if it goes infinitely in both directions. I don't think it does, but I mean, how would you possibly be able to answer that, really? When we're looking at things, then this map can help us, again, understanding what we're looking at. So if I look at, say, clouds that are going past my window now, I don't think that they're a complete cosmos in the way that say a person is a cosmos. So why would I say that? So a cosmos has some basic functions. It eats stuff, it digests stuff, it poops out stuff, it can have sexual relations, it can have babies, it's born, well, it's conceived, it's born, it lives, it dies. It can heal itself from injury or sickness. So it doesn't matter what scale you're looking at, a cosmos is going to have those attributes. And when I look at a cloud, from my understanding of clouds, I don't see that. I don't see it having all of those attributes, right? Of course, maybe it does, because we're all very limited in our perceptions. But I'm just saying that's not how I see it. I don't see it as having that kind of existence. Now, but one might ask, is it perhaps an organ? Is it an organ or a tissue of a larger body? Like if I look at my liver, the liver in my body doesn't have sex with another liver and make new livers, right? It doesn't work that way. That's not its job, so to speak, right? So as we look around us, especially as astronomers, as we look around us at various things that we see around us in the galaxy or whatnot, we can have that point of view of, well, is this its own separate creature that can have new creatures and live and die? Or are we looking at, say, at an organ or a tissue or a system within something larger? And I'll just give the classic example, I think, of this. Oh, come on, where are you? There we go. Share screen, window, boom, boom. Okay, so this beauty, do you see the orange and green and blue image?
Yes.
Okay, thank you. Just because I had trouble earlier. Okay, so this one is from the Herschel Space Telescope. You're looking at maybe 100 light years across. It's in our galaxy. It's in our galaxy. It's not too far away from us. And the broken astronomy, the broken astronomy looks at this and just sees a random collection of gas and dust. There's really only one tool in the toolbox for stuff like this. It's called a supernova remnant. Okay. When I first saw this, I was like, okay, we are looking at some kind of an organ or a tissue in the galaxy, but I don't know exactly what it's doing or why. It looked like a fallopian tube to me, right? That's kind of what a fallopian tube looks like, kind of. But it allows this idea, this bringing this concept of a cosmos to what you are looking at can just frame things for you and give you the right kinds of questions to be asking. You'll notice, for example, that there's these bright lines that are coming in to this structure. Those are not visible to human eyes. These are infrared structures. Planck and Herschel telescopes being infrared telescopes. Just incredible work that they've done and the images they've given us. But gravity does not explain these sorts of structures. It just doesn't. Gravity does not explain filaments. Whereas electricity naturally forms filaments. So when I look at this and I have the idea of cosmoses and of function, and I'm looking at this, I say it's not a separate being that I'm looking at, but it's an organ or a set of tissues inside of a larger body. In this case, it is some kind of an organ inside the galaxy, because galaxies have to have organs and tissues just like we do, and it's got to be just as complicated up there. So what you can kind of imagine, if it helps, that there's electric currents flowing in to this, whatever this bubbly thing is. Something happens in the bubbly thing, and then maybe stuff is brought back out to whatever is going on back here. Or maybe it's the energy comes in and it simply is deposited here, and something new is being created. Something new might be being created here. You can see again this kind of membrane structures. The light you're looking at here, it's false color. It's all false color because it's outside human visual range, but it's very narrow filters. So the blue lines here, if I remember correctly, is simply one transition line from an excited oxygen atom. The green is just one transition from an excited sulfur atom. So we talk about cross sections. We are looking at a cross section of a cross section of a cross section of something. And yet it still has all of this complexity and all these layers. Like there is clearly something different going on in the center there compared to everything else around it. And it's not some explosion. It's not a supernova remnant and things just exploding mindlessly out there, right? This is doing something. There's another element that I want to bring in. So if we look at the solar realm, one might say that its natural, its substance is light and electricity. Just for the sake of argument, right? That's our experience of it. This incredibly bright thing that seems to be putting out just this endless stream of light at all different wavelengths and electricity. I mean, the solar wind is basically electrons and protons. Like, you don't need to be much. It's hard to be more electric than that, right? Than it's just electrons and protons. Okay. But what's the matter of Earth? What's the substance of Earth? Well, again, it's more like water and dirt and stuff. And what I want to highlight, what I want to point out is that light can permeate and fill everything that our world consists of. Let me see, maybe I should back up. Like wood can be permeated by water. We know that, right? You can have a piece of wood, it can be dry, you can put it into a stream, and it's still the same piece of wood. You haven't melted it, you haven't destroyed it. It can be a nice little boat maybe, but it gets permeated, completely permeated by the water, because the water is a finer substance. Now the water can be permeated by gas. We know this. We know that all liquids here in our home Earth here are permeated by gas. All the gases that are in the atmosphere, they also are permeating all the water that we around, just different amounts and different settings and stuff. So you can have a wooden ship that is permeated by water, which is permeated by gas. Okay, they're all in the same boat. It's all in there at the same time. And what I'm trying to say is that it's also permeated by, the same boat is also permeated by light. Now, when I say light, I'm thinking a little more expansively. I'm not only thinking about what we can see. We can see about 1 octave of light radiations. To me, light is all of it. So infrared, and we know that infrared radiation permeates everything. Everything has a temperature. You get your infrared camera, you point it at anything on Earth, and you can see it because everything is permeated with heat, with infrared radiation. So I just say that to broad.
Uh-oh. Is that just my computer which can't see Michael, or can other people also not see Michael?
No, he has to come back on.
Okay, all right, let's try to do some troubleshooting here. Okay, I think he realized what happened. He has bounced off, so he should be popping back in, God willing. Yeah, he's got a way of inspiring a hell of a lot of questions. It's hard to even keep track of what they are. Yeah, Makos wrote.
That's why I wrote mine down.
Good idea, John. Okay, Michael is stepping back into the Zoom room. Where is he? And that didn't work. Cynthia, you let Michael back in, right?
Yeah, but it doesn't look like, it's just a black screen and there's no sound.
Well, when I joined 10 or 15 minutes ago, it did take a long time when it said.
Oh yeah, but that was only because we didn't notice that you were in the waiting room. It's a bit.
All right, sorry. Of course, it's different.
Michael, can you hear us? We cannot hear you. So,
Uh-oh.
Oh, he says he cannot hear us. Oh boy, that's.
No, he says he can hear you. He will get off again.
Oh, I can. I see. Okay. Yeah, I guess getting off and back on is the only way. It's weird. Unless, Michael, you might have to reactivate your microphone. That's probably it. Your computer is probably, if you go to the bottom left-hand side, there's a little microphone icon and a camcorder icon, which probably says unmute or start video or something like that. Bottom left-hand side of your Zoom screen, Michael. And if that doesn't solve it, I don't know what to do. So Michael can hear us. It's just not reciprocal. Oh, there he is.
Okay, it says that he has mic function and he just has to start his video.
Okay. Michael, can you hear my voice?
I can hear you,
Good. Excellent.
but I can see me.
That's okay too. And if
I can see you too.
Yay.
if you want to see everybody, Michael, then you have to go to the gallery option.
Yeah.
Yeah.
I get that. Thanks. Yeah. Okay. Did you lose me at? I was talking about how matters permeate other matters, and I give an example of the boat. Did you hear up to that?
Yeah, we heard how water permeates wood, gas permeates water, and I don't remember a boat.
Okay. There was this boat.
We're all in the
we're-
same boat.
We're all in the same boat. You were talking about light.
I actually
light.
thought he said boat. I thought he said boat.
He talked about the light and the light being special.
Which permeates.
So what I would, yeah. So if you imagine a boat is made of wood, and if you put it in the water, water is a finer matter, and so it can permeate into the wood of the boat. But then all liquid we know on Earth is permeated by gas. Gas is a finer substance. It can permeate the water. So if you see a boat sitting in the water, there's the wood permeated by water, which is permeated by gas. And then I was taking the next step to that the world of the solar system of the sun is a world of light, among other things, but it's a world of light. And all I'm proposing or saying that all matter on Earth is also permeated by the matter of the solar world. And so literally all matter on Earth is permeated by light and electricity and magnetism. And we know it's true at a simple level because everything on Earth has a certain temperature. And so it has a certain amount of infrared radiation that is going into and out of it at all times. Okay. But you can broaden that statement into wondering and pondering what other kinds of light is permeating everything. And so when we say that the Earth is part of the body of the sun, it's like, it's not just that it's inside the sun, the larger body of the sun, but it is permeated entirely by the solar matters, by the matter of the sun. And then we can take it one step further. I think it tells us that we don't really know what the matter of galaxies is. We're kind of stuck at light. That's as far as we've gotten. We're kind of stuck at light. But there's got to be some other matter, energy that is much, much faster and much, much finer, that permeates every sun in the entire galaxy, which then permeates every planet, et cetera, et cetera. And it doesn't take much. So hey, here we are. We made it to Easter. It doesn't take much to bring this to religious language, with the idea that whatever the substance of the absolute is, of the divine, it permeates everything. There is nothing in the whole universe that is not permeated by the substance of whatever that highest level is. So I just want to read the last paragraph of the lecture because I liked how it came out. If you believe that nothing else in the universe is alive, that is a belief, not science. You have done precisely 0 experiments to test that belief. If you believe that stars are not conceived, that is based upon precisely 0 experimental evidence. If you believe that love and yearning are not powerful forces for stars and galaxies and cells, okay, that's a belief. But if you call yourself a scientist, it is time to grow up and admit that these are beliefs based upon you probably know not what. Perhaps you no longer trust your feelings and trust only your instruments made of metal and glass. An instrument made of metal and glass is not alive and hence can only measure other things that are also not alive. A living being can only be sensed by another living being. One of us looks out and sees a dead universe. The other sees a living universe. Those who study the dead are always surprised by the new findings, while those who study the living often have an inkling of what they would find. Thank you.
That is an exceptional Easter gift. I knew it would be. It met all expectations and then some.
Cool.
Thank you. Thank you, Michael.
Welcome.
So we have time for some questions. Michael, how much time do you have, just out of curiosity, to set the tempo a little bit?
Yep. I have an hour, but we should make sure that we don't just draw it out.
Yeah. Okay, good to know. All right, so I'm going to throw out the first question that just popped into my mind. This morning, somebody sent me a really strange update from a NASA scientist talking about some new discovery. And this discovery is that there's a loose discovery of a loose black hole ripping through the cosmos, which they have a whole story weaved explaining how this loose black hole freed itself from the center of gravity when two galaxies smashed into each other, and now it's just gobbling up all matter it touches. You know, as if there weren't enough things to be afraid of. They're throwing out that I got to give them some points and creativity for coming up with a new one I didn't expect. How would you address this pervasive thought of black holes in general, let alone maybe not so much this particular spin story, but
yeah. Well, it kind of highlights, right, that's as far as the standard model can take you, is that there must be rampant destruction, pointless collisions. So I'd have to look at the data. I remember this was years ago when I was wondering about the veracity of the black hole model. And I really sat down, I looked at the data from a couple of papers, and I was shocked. I was shocked at how little data there is. I mean, literally, like, one of the papers was all built around some gamma ray emissions and some radio flux from one part of the sky. And they built this entire story. And what they did was they brought the mathematical model of a black hole. You bring that model here, right? And then you have your data, your gamma ray emission and your infrared radio flux. And then you see like how they might fit together and how the black hole model might fit that stuff. And you can make it fit because there's a lot of parameters that you can vary. And then, but then the authors, or who knows what, the editors, the authors believe that they're seeing a black hole, right? And I was just like, oh man, really? Now there might be a lot more evidence out there, you know, that maybe if I were to spend a few months, but I'm not going to spend a few months. So we don't know what we're looking at in a lot of these cases. And so if there is something that's traveling through the galaxy and in its wake there is a bunch of stars being created, there's probably a lot of different things that could do that. You know, I'm thinking about like if you ever seen time-lapse photos, I'm thinking I saw this great time-lapse photo of the development of the nervous system of one of these worms, you know, these planarian worms, and you can put a dye in the worm such that nerve cell creation will take up the dye, and the dye fluoresces, and it looks like, it's not like lightning, but you see this bright thing shooting down the body of the worm, and in its wake you see all these cells being created, right, in the wake of this nerve thing that's heading down the body of the worm. I mean, yeah. So I mean, I would tend to look at it more from a creative model rather than a destructive model. And if something's being built out there, yeah, that's as much as I can say about it right now, since I have no idea what data they're looking at.
Yeah, no, that's a good responsible way of handling it. John has a twofold question. John?
All right.
Actually, I have 3 questions. We'll see how it goes with the time.
Yeah, we're gonna have we probably will have a lot of people though lined up. So
okay, so so I'll throw 3 things out, and you can respond to one or more of them as you wish. You say there's one blueprint for the cosmos. That makes me think of Parmenides 1. The second, you stated that there might not be lower levels. I remember talking to Eric Lerner a number of years ago, and he related to me a conversation with Ilya Prigogine, in which he stated that if there was a discrete basement to the universe, this would violate the second law of thermodynamics. So my intuition is that there are lower levels. We just don't, at least for the moment, have any access to them.
Yeah.
And the third one is perhaps the one that's closest to heart for me, with respect to permeation. The father of the term mechanical philosophy, Robert Boyle, claimed when he invented his air pump that when he extracted all the air from a vessel, there was nothing there. There was a vacuum. And Hobbes fought this idea, saying there's still something there. We just don't know what it is. There's some kind of medium. So my intuition has always been that whatever particles we're dealing with, at whatever level of the universe, there's always a medium that permeates the particles.
Yeah.
And you could think, and that's exactly what you described today.
Yes. Well, Robert Boyle is like one of my favorite people ever. And I don't know if I've read that section of his books. Does he say nothing, or does he say there's no gas left?
I think he claims there's a vacuum.
Yeah, right. Yeah, well, I would have to.
And the thing is, the people who at that time believed in the vacuum believed in occult forces. Because everything ends up being external forces. There are no internal forces.
Oh, no. Yeah, I don't know. But I would agree that with Hobbes in that sense, and I think that would fit our modern paradigm quite well. Even if I do somehow take all the gas out, which you can't actually do, but even if I were able to do that, the chamber would still be filled with infrared light. Right, which is a substance, or it's an energy matter, which would still permeate the whole container, even if you were able to somehow take out every last gas molecule. About the bottom, so that sounds like such a. I was thinking Penrose might say something like that too, that if there were a lowest level to the universe, it would violate the second law of thermodynamics. I have no idea if that's true. Sounds like it could be true. Yeah, and I don't know. That just seems so far beyond our human mind to fathom. Certainly, I would say as a human, there's going to be a lowest level that we can measure, you know, but whether or not in reality there is a lowest level, who knows? You know, who knows? I don't know.
When you say lowest level, does that mean sort of like a limit to the universe? Is that like a spatial temporal limit, or does it mean something different that I'm not thinking about?
I think that's one way that a physicist would put it, right, in terms of space and time, since those are our two favorite fundamentals as physicists, space and time. Right, that there will be some smallest distance beyond which there is no distance, or some particle physicists might say some largest energy beyond which there is no larger energy. I don't know. I mean, these are such difficult questions, really.
Was there a third component to that, or do we move on?
There was the blueprint question. So I mean, were you asking why I might say there's only one blueprint, or what was your?
No, I'm just. I mean, I've read the Parmenides dialogue, and I don't understand it. And I know that Aristotle in his physics has fun attacking Parmenides, saying it's nonsense. But you're saying there's really only one blueprint. So if there's only one blueprint, well, maybe Parmenides got it right, at least at one level.
It's been forever since I've read Parmenides. I think I also didn't understand it. Yeah, you know, and it's. I just find it. I mean, I didn't make up the idea that there was only one blueprint for a cosmos, of course. But I do. It helps me. So it helps me think in terms of function. Is I guess maybe why it's part of this lecture is because every cosmos has to eat, and so you have to have the functions of digestion and elimination. You just see, you know, you just have to, so to speak. So the blueprint says the cosmos has to eat and poop. Now, how that specifically gets implemented can vary tremendously. And so in that sense, there's not just one blueprint, right? In that sense, the way that a cell poops is very different than the way that mammals poop. But still, the function is the same, and the function has to be there. Otherwise, you can't have a functioning cosmos.
Right. Yeah, and that idea that there's that it's not that things just come in and leave, but they're transformed within the organism is a very important component to making that entire process work, right? Everything
exactly.
is
Exactly, right. Yep. Yeah.
Thanks.
You're welcome.
All right, we have Stephen Doyle. Did you have a question, Stephen? Or I vaguely remember you did.
Yeah. I have just a question, or as much a comment, maybe. Michael, in terms of the connectedness aspect of your lecture, you know, the sun and the earth and us, are you familiar with the alternative medical domain of earthing and grounding?
Oh yeah. Yep.
Okay, yeah, because that one of the things that came to mind, just how important it is that we literally be physically connected to the earth and not just out in the sunshine getting vitamin D.
Yeah. You know, I did some experiments with that recently. I just took a voltmeter, just a decent voltmeter, and we went outside, a bunch of us, and so the black lead, the common ground, we stuck into the dirt. Finally, you get to put the ground lead into the ground. So we put the ground lead into the ground, and then we held the other lead, and we had it at the either 200 millivolts or 2 volt setting, depending. And when the shoes were on, the voltage would fluctuate around 0, and it would be like plus 10 millivolts, minus 20 millivolts, plus 50 millivolts, minus 30 millivolts, just kept fluctuating around, right? As soon as we took off our shoes, the voltage went zoom right down to about negative 180 millivolts, and it just kind of hovered around there. So that, and we were like, oh, that's it. And it happened with all of us. It was so clear of a signal, right? And then we were like, well, I wonder what the trees are up to. So we took the red lead and we stuck it into the bark of the trees, several different trees and bushes that were around. And it was a very similar number. It was in like the 200, 300, 400 millivolt negative, just like a person. And then we tried standing on different things like concrete and asphalt. And just out of all of that was just, it was such a vivid just measurement of exactly what you just said, what you started with, is that this idea of this earthing idea, that it actually really matters. It really truly matters that we are touching the dirt and the grass and the whatnot with our skin, right? That actually, it actually matters. And so this was a few weeks ago. I did this with a group of people, and I'm still trying to ponder, what all that, what it all showed us. I mean, it was such a clear result.
What's interesting too, your trees comment really twigged me, because I've read elsewhere that cancer rates are lower in populations that live near wooded areas or where there's a higher concentration of trees. So it's yeah, quite fascinating.
Yeah.
Thank you.
You're welcome. Yeah.
Yeah, medical science in the future is going to be a very different thing from what it's taught today. Huh? When doctors are trained to think about the galaxy.
Right. and trained to ask questions like, well, what's your electrical environment, right? To explain your electrical environment to me. Yeah.
That's good. We have Kelly, who's been waiting for a bit. Kelly, go for it.
Can you hear me?
Yes.
Great. Thanks, Michael. I love these topics. They're just amazing. There's so many directions we can go with these things.
Yeah.
Yeah, one of the things that struck me when you're talking about like in the solar kind of system, the Earth and the sun, and like I get the impression like these things, certain phenomenon seems to happen when at that point where the sun is rising and it rising and when it sets, and it's like it's almost like there's like at that very point when it just starts coming over the horizon, like all these things happening, or like all these things start happening with the atmosphere, the troposphere, right down it like into the earth, and then I think of things like we wake up and sleep, and most people, like, well, I do anyways, when the sun starts coming up, I start to wake up, and a lot of people, they have like a dream state between waking and sleeping, and then and even when you go to sleep, you kind of go into this, it's like a pre thing before you actually fall asleep. And it's almost like there's detail in there, like, well, maybe like in my dream, maybe that detail could give us clues to like whatever you're looking for, like in the geez, I don't even have all the words for it. We need more words in these new sciences. But yeah, I think there's a connection there someplace. Could you expand more on what you learned more, like when the sun is rising and setting, like what's going on?
Yeah, I'm still stuck on your great connection with the dream state there, and yeah, that's a really cool.
Yeah, I could talk all day like stuff like this.
Yeah. And well, so just a few words about the electrical aspect. I don't know, for some reason it really helps me. I should have brought a little ball to spin, but you can imagine that if you pull back, I said this just a half hour ago, but think about it electrically, that you have these incoming and outflowing currents, and then underneath or inside of those, you have this spinning electrical element, because the Earth has a lot of its own electrical attributes, conductive stones, less conductive stones, the oceans. There's a lot of electricity in the Earth itself, and it's spinning underneath. It's spinning underneath this outer coil or something, and it just when I pulled back and tried to take that perspective of what's the off Earth perspective of what's going on here, and then I saw that that these inflows and outflows primarily take place at sunrise and sunset. And so I kind of got this flash, like if you were to speed it up a few thousand times, there's this whirring ball underneath these two electrical inputs and outputs, and one side of the ball is illuminated directly by the influence of the sun, and the other side, is just the opposite. It's getting none of that influence from the sun directly. And when I spun it fast, like I just kind of saw that, wow, yeah, that something's coming in. And like you said, when the sun comes, see, we of course say it from the Earth's perspective, when the sun comes up, rather than saying when my portion of the Earth spins into the light. We all wake up, we run around. How do we get that energy? It's a mystery, right? How we get energy when we wake up in the morning with all this energy. That's a mystery. And then we run around and we fight and we achieve things and we have failures and we hurt each other and we save each other, and then we just collapse down on the other side and fall asleep, right? And so if that's spinning, and then just the image, like I'm saying, this image that I got, the image of all those experiences and all the love and the hate and the fighting and the achievements, and just flying back up to who knows where. And I love your bringing in the dreams, because I think I experience it more waking. I think it probably depends upon the person, but you're right. That halfway place when you're falling asleep, it's different. It's different than the halfway when you're waking. It's a different kind of transition.
Like, I'm thinking like with shadows, like we when we look at a shadow, we see the light and the dark part of it. But what's like right in that middle? What's in that line? Like, could we is it possible to dissect like that actual point, I don't know. It's just some crazy thought, but
it is, because in the real world, there's always that transition. I mean, you can create some wacky physics engineering setup where there's an exact shadow, maybe. No, you can't actually. So there's always that transition from light to dark.
Yeah, I don't know. Can I mention another thing? Yes.
We have a lot of people who want to ask a question, so maybe if there's time, I'll circle back to you afterwards.
Thanks.
Okay, the next person who's been waiting has been Rich. Actually, Harinder had a question. Harinder, are you still there?
Yes. Can you hear me now?
Yes.
Yep, I can
hear me now.
Yeah.
Okay, so my question, actually, I unfortunately took you guys almost half an hour to allow me in for whatever reasons. But so I missed the earlier presentations about Parmenides. But my just a general comment would be that we are now talking about mystical areas that have been discussed in scripture. And we may not have the tools at a physical level to tap into these things beyond a very, very sort of primitive level. Things like, we know there is electricity and everything is electricity in our bodies and so on. So speaker mentioned at some point that there is a higher energy finer than light. So I had written down at that time, do you think there's any connection to neutrinos? But I will mention what is mentioned in John and in other scriptures also, that the word permeates everything. So whatever it is we have been discussing about at the lowest level or the highest level, what's down there which we cannot measure, it may be that mysterious power. I don't know. I'm just sort of throwing out my thoughts here. But there is also this thing about neutrinos, which is that the smallest element that scientists have discovered. And they can't detect it directly, but they detect it by certain experiments and so on. So I'm just wondering if you have any kinds of thoughts about that.
Yeah. Yeah. Well, I want to first address what you're saying, for example, like with the opening of the Gospel of John. I think it's completely, it's, in my mind, it's right on track as a scientist to say, okay, you know, light brings me this far, but what are the other things that I know? And so things like intuition, feeling, inspiration, I don't think those things have a speed, or their speed is infinite or something, right? They don't seem to have a speed that's bound by the usual rules of space and time. And I think we are so done with the days when somebody would say, oh, well, a physicist can't study that then. You know, if you're proposing there's something that's out that goes faster than light, than a physicist, and it's like, no, okay, that might have been true 70 years ago. It's not true now. It's just not. And I sincerely hope that more and more trained, you know, scientists, physicists start looking in those directions. You know, intuition, inspiration, they are real. They're real, and they carry force. You know, if I get an inspiration to do something, it makes me go do it. Okay, so at a basic level, as a physicist, you're like, you know, if the billiard ball moves, it means there was a force that hit. You know, that's the language of physics. So if I get an inspiration and then launch into a month's worth of work, that's a pretty big force. That's a pretty big force that would make me devote my energies for a month to something. Okay. So I'm just saying that I recognize that as a real thing. It's not some imaginary thing, right? It's a real thing. Yeah.
But tapping into it and measuring it, and how do you measure that real thing, which is coming sort of invisibly? These are things that I think, I just think are tools of scientific measurement are somewhat primitive at this stage, at least, even though they may seem advanced. We're just sort of scratching the surface of whatever complexity is out there.
Yeah. Yeah, scratching the surface, and scratching the surface with ever more limited instruments.
That's
so
right.
that the scratch marks keep getting thinner and thinner. Yeah, it's like a runaway exercise. And what's it say? Oh, the neutrinos. Yeah. So it's been a while since I've studied them, but back 20 years ago, I was reading about them a lot, and I had the feeling that they were an example of something, right, that's not quite real at our level of living or perception or something like that. That they have a mass? It's not clear. They might have a small mass. Oh, but this experiment says they don't have a mass. Oh, but this experiment says they have a slight mass. You know, and then the speed at which they travel. The supernova experiments seem to show that they travel at the speed of light. Okay, I'll give you that. But I forget what the other experiments were at the time. They're like, oh, but it seems to be going a little bit faster than light. So all I'm saying is that looking at the raw data that one can obtain by studying these particles, it has all the attributes of you're studying something that's not quite in our world. It's kind of in, but not really. So that was my sense of the neutrino, is that it's something that's not fully in our what we call our usual world.
But that's not your idea of the higher energy, what you mentioned, that something higher than light. That's not, you don't associate that with neutrinos.
Well, it certainly could be. It certainly could be.
Final point, I'll just throw this out there. There was a discussion about dream states and waking and sleeping. Scriptural philosophy says that there is inside this physical body, there's an astral body, and beyond that, a causal body. And we may be intersecting between those bodies at such moments. I'll just leave that out there because I can't make any. That's what the scripture says, that there's a inside this coarse physical body, there are more subtle bodies, and the subtle bodies may be moving around.
Right.
Some people have control, like Tibetan monks are supposed to be able to travel astrally out of their bodies.
And so
I'm just going to leave that there because we don't know.
Right. But see, that's part of this conundrum of the dead end of physics currently is we keep insisting on more instruments that are more dead. So I want an instrument that's pure glass or pure silicon, or I want an instrument that is pure this or that. So it's like this fear or this inability to acknowledge that we might need different kind of instruments. And so what you're saying is along those lines, that we have faculties in us. The human body is the most advanced instrument that we know about, you know, and the human body is so much more advanced than any of these, you know, other instruments we build. And so why have we been somehow dogma isn't even a strong enough word? Why have we been it's like we're out of our minds. It's like we're crazy. Like we refuse to acknowledge what we experience. I must only look and see what the CCD camera picks up. I mean, it's a little crazy. There's something a little literally crazy about it.
That's why I really liked your I mean, this whole like divide between metaphysics and physics is a little it's a little troubling in popular society, but I like the way you weaved it all together, and your concept of the higher domain of being a place, so-called, for lack of a better word, that doesn't have a metric of space, but rather instead of distance in the naive sense perception concept that we're used to speaking of it, there's instead the idea of usefulness and thus beauty to greater or lesser degrees, which for me reminded me a little bit of Nicholas of Cusa, who generated a really great metaphor of the universe being a place where he said the universe can be likened to a sphere as an allegory where its center is everywhere. And you have this idea of God's presence as well within that concept. Cusa's a man of the church, but he's a metaphysician and a physicist at the same time, lawfully so, as you are. and when he cites a lot the Greek translation from John's writings, and he makes the point that it's logos, which we often in the English translations of the Bible often see the word, the term word was at the beginning, but the real term is logos, which is really an idea of thought, of reason, which means, I mean, that's the whole idea of function anyway, right? That function's an effect of reason, which means the mind. Why would there be a place in the universe where there would be no presence of mind? Which I guess that's the black hole idea that they're trying to put into that.
Exactly, right. That's the blessed black hole, right?
Without opening a whole can of worms, I'll just say that according to yoga, India, and so on, mind is a creation of spirit. So this is such a big discussion. I'm not going to take more time. But mind is the highest level we know. But beyond that, there is spirit which created mind. So I just leave it there. That's all. So logos would be the spirit in from my understanding, but you're right, you're associating with it with the mind, which is a creation of the spirit. But let's just leave it there. I take it too much time. Thank you.
That's about it in this case. We'll leave it to that. Cool. Richard's been waiting for a bit.
That discussion could really it could go on, couldn't it?
Yep.
It's wonderful. Digestion, elimination, and transformation seems to be an integral part of cosmoses. That's kind of three things. That there is always something that becomes something else.
Yeah.
Step down, going in whichever direction they go. Just to put that in there, a cell of everything has this process of energy transformation. I would love you to speak more about how we give back, how life gives back electromagnetically. But I was also curious about in our multi-layered atmospheres on the Earth. I see in the diagram it's sort of life, Earth, and then solar radiations of some sort. the planets, how do they fit into acting between the sun and the earth? And then also, what relationship do you understand the moon to have as a place in transforming, modifying radiations from electromagnetic radiations from the earth? I know I'm complicating things, but the moon, the planets intrigue me. Yes, in this model.
Yeah, the planetary world. So one idea is that that the planetary world is not the same as the solar world. And so, but the planetary world is within, it's within the body of the sun, but the body of the sun is something that is much larger, much more complex than we can really fathom. And so one idea is that the planets are all exchanging electromagnetic information constantly. And so we know this at a simple level, like if a solar flare whacks into Jupiter, and then Jupiter's magnetosphere goes wah, 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 that Earth's magnetosphere will respond to Jupiter and go whoop, 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 so they are directly connected. It's a level of connection that just has not really permeated into the common, the textbook level, so to speak. And so anything that happens electromagnetically on Earth is felt by all of the planets, more or less. Who knows what the factors are that determine the details there, but we do know that it does affect, things do affect what happens on one planet affects what happens on another planet. So when this idea of us waking up, living our day, falling asleep, waking up, living our day, falling asleep, and then these currents that are coming in and going out, what I imagine is that if you somehow could add together all the day of, so half the world's awake at any one time, so add together 3.5 billion days. What kind of an average is that, right? You're doing some kind of an average. Of course, maybe some people, like a St. Francis of Assisi, I'm sure sounds a much clearer note than 100 million other people. But let's ignore that for a second and just say you have 3.5 billion days that you average all together, and then that goes out to all the other planets, and all the other planets get that as maybe a bit of food, or maybe as a bit of information. Maybe the earth looks red today, or whatever. There's some kind of perception. There's some kind of perception, or maybe even nourishment that is communicated to every other planet in our solar system. And it's going on constantly, right? It's going on constantly. It never stops, ever. I can get a sense of the vibrancy. There's so much energy in that scenario that I just painted.
And the
moon. That kind of addresses your planet question, right?
Yeah, it seems like is life dependent on the moon? If there was no moon, would we have life on Earth?
Who knows? That's one of those hard to run the experiment, right?
It just seemed to play such an important role in, or not an important role, but a visible role, a measurable role in cycles.
Mm-hmm. Yeah, just, all that is right, super clear, right? That and there's something strange about the Earth's moon too. Look, we don't know much about other solar systems, right? So we have a very limited data set. But if you look at our solar system, our moon is huge, and it's pretty far away. And so the influence of our one moon on the poor Earth it's, I mean, it's like the Earth can never have a rest, because it's always got this giant thing that it's swinging around, right? Like Jupiter has like 60 moons or something like that, which is hard, imagine that, just ponder that for a while. Like Jupiter has 60 moons, but they're so small compared to the mass of Jupiter that you can hardly even see how they affect the trajectory, say, just if we just look at the trajectory. Whereas on Earth, yeah, it's this image, like just this never ending kind of,
a topsy-turviness, perhaps.
yeah.
Mhm.
Yeah. I mean, even down to, we know it affects us psychologically, right? That's been known forever, that various forms of madness and violence and incoherence just follow the moon exactly, right? No mystery there. It's been following it for for millennia. Yeah.
Yeah, and I'll just throw in one line. The idea of planets is related to your notion of inspiration, if we believe astrology has legitimacy. So the planets are writing destinies or implementing destinies that are being written. Again, I'm just going to leave that there.
So I mean, I think we can, or from a physics point of view, we can approach to what you just brought up, is to think about. So remember I said how imagine the Earth is spinning and you have at any one time 3.5 billion souls that are sending up their day in this giant average, whatever this average energy goes up is. But you can look at it the other way, which is I think what you're bringing up, is how does that influence, say, of Jupiter? How does that influence that average of those 3.5 billion days that just were lived? And I mean, I know it does, but I haven't studied it, but I just can tell that it does. So there is some direct effect that these planets have upon the mass of humanity. I don't know how one makes the transition to individual, like how does Jupiter affect me personally? Don't know. That's a very different, I think it's a very different kind of question. But I think we can look at the averages, look at the overall influence. It has to be there. It would be crazy to say, I mean, from the discussion we're having and the terms we're talking about, it would be silly to say that the planets do not influence, humans on Earth. That would just be you'd have to have some giant insulator out there in space that would be blocking the influence.
Mm. Yeah, there's definitely a lot of place for the mind to move in this domain. Nikos, if you're still there, you can ask your question.
Yes, thank you, Matt. I'd just like to say how good your lectures, yours and Cynthia's lectures that I've been listening to over the last while. There's such a wealth of helpful connectedness. And this is just another example. The things I thought to throw out there, like Arinda, a couple of things for you. That science has led us astray, I think. And this example of yours, Matt, where you talked about the rampant black hole, that kind of message which has been put out to us, it just gives us a sense that we're powerless in this universe and that we are such tiny creatures. And if we think back to how the Greeks saw things, that man was an important part of the cosmos, that man had a place, had a job, as if you like. His intervention was important, even in just trying to understand the world around him. And I think many of these things were led astray with the mechanization of science that happened when Cynthia talks about Leibniz and Newton, that kind of thing, where a world picture was taken away and something else was substituted, which lessens man and means we hand over to the experts, the scientists, we hand over to them the explanation, and we lose our sense of being, we lose our sense of cosmos, where we belong. And I think when Herinda talks about the yoga and the Vedic scriptures, there was a sense of belongingness, which is important to us. And when Dr. Michael was talking earlier on about the structure, that there's levels in the universe that permeate each other, and that, you know, the old saying, man is a measure of all things, that in a sense, that was an important thing. It didn't mean we're big-headed necessarily, but we had a position which we could try and fill. And if there are levels of things penetrating, that maybe the universe is in us as much as we are in the universe, and that we have access, or could have potentially access, to intuitions and intelligence, which would help us to find our place and be more coherent in the world. I think that there's so many things that have come up this evening. It's been very interesting. And it's good to show that when people get together and just kick a subject around, how much we can come up with. But again, it's the forum that you present, Matt, that in a way that gives us the opportunity then to share together and to get all the meaning we can from experts like Dr. Michael, who can get something going and give us an opportunity to, you know, think about things and really try and assess this mysterious world that we are actually living in. So thank you all, everyone. It's been very interesting.
Oh, very well said. Very well said, Nikos. Yeah, there's that. I see it as some kind of a dual trajectory where, yeah, we get the science, and the science we're able to explain these things, and matter, and we can do more things with matter, and we somehow think, oh, we've liberated ourselves from all this superstition, and look at us now, technology, matter, smart, blah, blah, blah. And then that somehow is direct. It's the opposite is also happening, that we are becoming, I'm just repeating what you said, we're becoming disconnected. We think the mind thinks we're connecting, the intellect thinks we're connecting, but all the rest of us does not experience it that way. The rest of us just feels this horrible, like, anguish of being disconnected from everything in the process.
Mm. That thing you said about being grounded to the earth, you know, that kind of thing, Michael, when you said that experiment, it's just physical proof of that point, isn't it?
Oh, right.
I mean, exactly.
Right,
it's just plain as that. We all should realize that as a common sense experience.
Yeah. Yeah.
Yeah. Thank you.
You're welcome.
Nikos, I just like to thank you for that excellent contribution. And I think if people miss what Nikos just did, it's really special. It really struck me because everything Michael has been weaving was made really explicit in the sense that individually, you know, like, and we've been talking about Plato too, the Timaeus, the Protagoras, the Parmenides. These are all very important dialogues that flesh out these concepts in fun ways. But we're all individual ones. We're monads. We're souls. We have unity, but at the same time, we're also parts of broader wholes, right? Both, just like the planets are parts. They're all individual, but they're parts of a broader system. And you could do a lot individually, and we need that time to ourselves to think, to ponder in silence. And at the same time, because we're social beings, this little group of 23, 24 people that are meeting up live right now are also a unit with parts, but the unit is in some ways more than the sum of the parts. And just by virtue of what you've done, Michael, you just sparked a passion which has created a giving and a taking, where I could feel everybody is receiving your insights and at the same time processing and sharing back into the system, which is sort of transforming the tuning of the whole symphony a little bit. I like this a lot.
Yeah, I agree. I
Yeah.
agree.
Yeah. Very natural. Sue writes, one blueprint found in life, matter, form, and sound breed. Sue, do you want to elaborate on that, or do you want to? Is that just?
Yeah, sure. Hi.
Hi.
I when I discovered Dr. Michael years ago, I was just so inspired on so many levels, and he had spoken in other talks about life, matter, form, and it reminded me too of a number of years ago. I studied a form called Uzazu, and in it they brought in 8 primary vowel sounds, and through studying the sound, they would make the sound, and out of that breath movement patterns emerged that laid out matching the I Ching. So you get awe and which is heaven and earth, or sensory motor, that sensing and that responding. And then the U and O, I won't go through them all, but the U and the O was like the digestion. It was U is filtering in, taking in, ingesting. Exhale O is the deep integration. What we take in and it becomes part of the self. And then the exhale U is the differentiation, the elimination back out into the universe. So I was just wondering about the aspect of the Trinity that could be sound, matter, and form, and thinking about Hans Jenny and sound giving, the vibrational sound giving rise to the forms of matter that we see throughout the universe, and the planetary bodies that have their own distinct sounds. And yeah.
One of at the planetary level, the electromagnetic connections between them, there's waves that happen that are completely analogous to sound waves. So the way that we experience sound here on Earth in our molecular atmosphere, you know, the molecules go back and forth. It's not like wiggling a string where the string goes up and down. Like if you and I were holding a string and I wiggled it, it would go. It's a different kind of wave. And so there's exactly analogous sound waves that connect all the planets electromagnetically, but the frequencies are not necessarily, or they're not what these instruments can hear. If we had a different set of eardrums, we could hear the planets singing and you know, influencing each other, and who knows what they'd be saying. I don't know, but I'm just saying that the principle of sound, is much bigger than us just talking in this atmosphere on Earth.
Yeah. I encourage people to check out Kepler's book 4 of his Harmonies of the World from 1619. Well, the whole all 5 books inside of that wonderful piece of work are really great. But are you familiar with? Have you looked at Kepler's approach to the harmonies?
It was a while ago.
Yeah, it's cool. He makes a point that in his system whereby he takes up the Pythagorean hypothesis of the harmonic proportions of the planets as being sufficient cause for why they are in the positions that they are instead of some other configuration. He's like, well, what about the musical geometries and the proportions that arise from those discoverable proportions? And he points out that Earth at aphelion, perihelial distance, well, using their angle and speed at the closest and furthest distance from the sun, takes up the mi and the fa. Yeah, and he makes a little joke saying maybe that's why we have so much misery and famine on the Earth. He's a funny guy.
A real knee slapper.
Yeah. I mean, he's living in the 30 Years' War at the same time, but it's an interesting idea because he's living in a time of great despair and war, and Germany's losing half of its population in these imperial Venetian-funded wars, you know, forever wars, and he's intervening on it by making a discovery of the harmony of the universe and God's design in order to give people a higher sense that there's a better way, a more natural way for us to be than to fight each other over, you know, little scraps of land or religious differences or something like that.
Yeah.
That's
wow.
And you missed last week when I gave my lecture, Matt. There's a passage in the dialogues of Galileo where Galileo, who only believes in local motion and doesn't believe that that there's any long distance connection between the celestial bodies, criticizes Kepler and calls him childish.
Wow.
And the thing is that I couldn't find it in the English translation. I could only find it in the opere, which were published in the early 20th century, but I couldn't find it in the English language, which is a common thing in translations. You really have to check whether the translator was dutiful in translating the full, not just the words, but also the intent.
And in English, I mean, I didn't know that about that Galileo would. I mean, childlike, yes. Childish, no. I would not say Kepler is childish, but he's childlike, maybe. Oh well, it's a. Yeah, I mean the breadth of Kepler. Man, I mean, Matt, you probably have given whole semesters on Kepler, right? Just the breadth of his understanding is just hard to imagine.
He's pretty comprehensive, yeah. I mean, even the concept of the planetary souls, he's developing in a pretty thoughtful way in the book 4 of his harmonies. Yeah, it's he's also studied Da Vinci, and Da Vinci is also looking at the same effects of looking at the river systems of the earth as veins of an organism. Like all of these great thinkers who are intersectional, combining and uniting all of the different seemingly disparate branches of thought, are all sort of zeroing in on the exact same intuition and insight, which is clear when you see these beautiful geometric relationships of the organization of planetary bodies and solar systems, and little things going on in the micro, the micro domain as well, or plant life. There's fractal geometries, there's golden sections, as above, so as below, and yet we're still told to believe that all of this is just chaos, randomness, and our naive senses convincing us that there's order, when in reality, true scientists know that it's all meaningless, nihilistic chaos.
So I found the passage. Predomini qualita occulte e simili fanciullezze. So in English, influences, occult qualities, and similar childish explanations. This is Galileo talking about Kepler.
Yeah. Wow.
And it doesn't end up in the English translation.
Yeah. Oh boy.
Arrogant.
Okay, we got just a few minutes left.
I think this is probably a great way to end. I mean, Michael, if you have any parting thoughts you want to end this little Easter gift on, that would be a great time, or we could just basically close it up.
No, I don't think I have anything particular to close with. It's been a pleasure. I've loved it. Thank you much as always.
Absolutely. Thank you. And I would say that, as you pointed out at the very beginning, this question of longing, of yearning for something more, and that which is beyond our sensual material domain, is something which I think is more important and often overlooked, but is really the source of so much. All of human history, I don't think, could be accounted for if you just ignored that factor of inspiration, and how a metaphysical phenomenon like inspiration could cause the material world to change, right? To the point that lives, nations are built. All of history is shaped by these immaterial but real phenomena.
Yeah.
And I think that this is the lack of appreciation for this reality is in large measure at the heart of our current crises, which are just, I mean, it's a perfect storm of crisis that's hitting the world right now. So if we're going to be able to get back on the path of natural law and create creative love the way human beings were designed to, I believe, and I think we all here are in accordance, that we're designed to be creatures of reason, love, and creativity, then reviving a rational basis for this way of thinking of science that you've just presented is absolutely vital. So just these little incubators that we're doing right here as an exercise is so much more than just a way to pass a Sunday afternoon, but I think it's really an expression of the entire universe expressing itself in a very real way right now at this moment. So, Michael, thank you very much for giving us a little taste of the whole universe and maybe a bit of God's mind.
You're very welcome. My pleasure.
All right.
Okay, till next time.
All right, till next time. Bye, everyone.
Thank you.
Bye. Thank you. Thank you. And good
Bye,
night.
everyone.
Okay. Good, everyone.
Yep.